Okay, welcome everyone. My name is Hugo Cornelis, and I'm going to talk about execution plans today. I'm happy to have everyone here. I always like to be able to watch the people when I talk to them. That's unfortunately not possible, but I hope I can still do a good delivery of this session. My name is Hugo Cornelis, and I make SQLServerFast.com. SQLServerFast.com is a website that I created a few years ago because I love execution plans, but I hate the lack of documentation about execution plans. In order to fix that, I decided, you know what, I will just start building my own documentation for execution plans. So that's the execution plan reference. It's called a reference for a reason. It is actually a real reference. It's not a tutorial style. It's deep, detailed information, and definitely not where you want to start if this session is, if you are the intended audience for this session. However, I also have started to create a series of training videos called the SQL Server Execution Plan Video Training. And if you really want to go into all the details of execution plans after this session, you might want to give those a try. Unfortunately, I am unable to give them away for free. The first set is for free. The rest I do have to ask for some money, but I see I started the wrong presentation. 1 second, because this is the version that doesn't have the code in it. My bad. Give me 1 second. I should have started this one. So like I said, if you want to get the video training that is already completed, the part that's already completed, until the end of March, you can get a 10% discount on all the videos that are available with the code DATASETPORT, which is of course short for Pordenone. I hope I pronounced that correctly. There's also some other content I have available. I have my blog on SQLServerFast.com. I have some longer articles. And very important, I have a library of resources where I have the slide deck and demo code for all my regular sessions, including this one. So if you go to SQLServerFast.com and then use the menu options, other presentations, presentation resources, you will be able to download the slide deck and the demo code you're seeing now. Well, actually the one I just showed before that doesn't have the code, because I want to give the code only for the people who are here. And if you missed it, don't worry, I will repeat the code at the end of the session. I do a lot of other stuff as well, but we are not here to talk about me. We're here to learn about execution plans. So the only thing you really need to remember about me is my email and my Twitter. If you have questions, if you run into any issues, if you want to know anything related to SQL Server execution plans or other stuff I do for the community, please mail me, tweet me. Understand that I may not always respond immediately, but I love engaging with the community. So use these. We are going to talk about execution plans, and we are going to go through several items. I want to talk about why they are important. So why should you care? Well, you are here listening, so probably you already have a reason to care. But let's go through why execution plans are important anyway. And then once we all care about execution plans, the next question becomes, where do we find execution plans? How do we read the execution plans once we found them? And then we're going to talk about properties, a very important element of execution plans that especially people who get started reading them too often overlook. And then depending on how much time we have available, I will run you through 1 or 2 examples of execution plans for queries and show how you can piece the elements together to get an understanding of what is happening in those execution plans. That's a bit depending on time left. If during this session you have at any time a question, please type them in the chat window. I hope that one of the moderators will be able to read it, and they can then just unmute and talk. If your question is overlooked, I will try to keep an eye on this chat window myself as well, but I know I'm bad at that. So if your question is overlooked for too long, just unmute yourself and start talking. I really want to answer the questions, so please interrupt me if needed, but do the chat window first. So let's talk about why should we care about execution plans? Who cares? Why do we even want to read them? Well, to understand the importance, you have to understand the difference between traditional third generation languages, or also called procedural languages, and the fourth generation language, also called SQL Server, or rather SQL languages, because that's general for all SQL type languages. So traditional third generation languages, I always compare them to how I view my morning routine. The alarm go. This example is pre-COVID, by the way. So if you hear me say stuff, you're like, wow, you shouldn't do that. That's because it's a pre-COVID example, but I keep using it because it clarifies stuff. So my morning routine is the alarm clock rings, I hit the snooze button, a few minutes later it rings again, I get out of bed, I go to the bathroom, I take a shower, I brush my teeth, I get dressed, I eat breakfast, I get in the car, I drive to the office, and I start watching cat pics. I start doing productive work. That is a step-by-step description of all the steps I take to go to the office, from my bed to the office. The order in which I state those things is important. If I reverse the order and get dressed and then shower, I still do all the steps, but the end result is not the intended result. It's not really effective. So here it is important that we describe everything in the correct or the most efficient order. So for programming languages, it's the same. A third generation language is a step-by-step description of what the computer should do. Because computers is very good at doing the same thing over and over and over and over and over again. Third generation code often deals with different ways to handle a collection, like various ways to implement a loop. For instance, you load the first element into memory, you do stuff, then you read the next element, and if there is more, you repeat this. You can do this in different ways. Those are called algorithms, and it's the developer who chooses the algorithm by modifying this step-by-step description. So obviously that means if your code is slow, the algorithm that was chosen is not efficient. And we can blame the developer because the developer wrote the code and the developer can fix it. All of this applies to third generation languages like Visual Basic, like C#, like many other languages, but not to T-SQL, or rather to SQL languages in general. SQL, structured query language, is a fourth generation language, and in fourth generation languages, the code is actually a concise description of the requested end result. So returning to the example of my morning routine, the fourth generation equivalent of my morning routine would be my boss sending me a text message saying, Hugo, we have an important customer in the office tomorrow, so make sure that you're in before 9 and dress appropriately. And that's it. That's all she specifies. She doesn't care whether I choose to first take a shower and then brush my teeth, or to first brush my teeth and then shower, or whether I choose to brush my teeth while showering. She doesn't care whether I do a very extended breakfast by setting the alarm clock early so that I can have a long breakfast with my wife and discuss the day, or whether I have a package of prepared bread already and I can just grab it off from the refrigerator and eat it while in the traffic jam. It's completely up to me how I get there. The only thing she cares about is that I am in the office by 9, dressed appropriately. That's all she cares about, nothing else. And that's the same thing with SQL languages like T-SQL. We only care about the result and we don't care how the computer gets there. So instead of describing a loop where elements are handled one by one, we describe a logical application pretending it's all happening at once. In reality, the computer still processes one element at a time. The computer cannot process a million rows at once. So here, it is SQL Server that does a translation between the set-based logic of our queries and the one step at a time processing that the CPUs still actually do. And this is done by a very smart piece of software called the Query Optimizer. This Query Optimizer is included in SQL Server as part of SQL Server. It's the effect of thousands of hours of research and work, and it does a very good job, usually. So the Query Optimizer chooses the algorithms. Based on all the information it has available, it tries to figure out the best way to give you the results you want. Now, when the code runs slow, the problem is my boss still blames me. I didn't write the code. I didn't choose the algorithm, but my boss looks at me and says, the database is slow. Do something. And sure, I can say, hey, it's not my fault, it's the Query Optimizer. But you know what my boss will say? I didn't hire the Query Optimizer. I hired you, Hugo. You are the one who's going to fix it. So that's where it becomes important to understand that even though the Query Optimizer picks the algorithms, that doesn't mean it's always 100% correct. There are sometimes cases where, for various reasons, the optimizer doesn't make the best decision. Perhaps because we run into a shortcoming of the optimizer, perhaps because we wrote our query in a terrible way, or because there are not the good indexes available. There can be multiple reasons for that, and they all can result in slow code. So we need to fix that. Now it's important to know that T-SQL is not a pure SQL language. T-SQL is a combination of this set-based query code with third-generation type procedural code. That means that slowness can be caused by multiple reasons. It may be that the code that is running uses a lot of procedural code. If that's your issue and your code is slow, I always recommend start rewriting the procedural code as set-based code. SQL Server is completely optimized to be as effective as possible when processing set-based code. When processing one row at a time using a cursor or using client-based logic where one row at a time is done, SQL Server is far less effective. So always try to rewrite a set-based code when possible and where possible. But it's also possible that you run into an issue, your boss is yelling at you because the database is slow, and you figure out it's a single query. There's one single query that needs to do a bunch of work, and it finishes in 5 minutes, but it should finish in 5 seconds. Then we have a problem. Then we have a single query, the optimizer chose the algorithm, and apparently the algorithm wasn't fast enough. That's where we want to know what is the algorithm that the optimizer chose. And that's where we finally get to the topic of this session, execution plans. Because if you want to know what algorithm the optimizer chose for a query, you look at the execution plan. And that is why you should care about execution plans. If you care about performance of SQL Server, you need to invest energy in understanding execution plans. So, where can we find them? Let's find execution plans. Now, again, this is also a question where there are multiple answers. If you are a production DBA and your production server is humming along and you get some alerts that some metrics are hitting thresholds where you want to have alerts, you might be tasked with finding problem plans. That's a very interesting topic, but it's off topic for this talk, simply because in the interest of time, I can't cover everything. So there's a lot of sources you can use. You can use the plan cache, a query store, extended events, trace preferably not, but you can use it. Monitoring, third-party monitoring tools, various DMVs, and none of this is in scope for this session. The end of the session, I have a slide with resources. One of them is a book by Grant Fritchie that I tech edited. And he spends 1 or 2 chapters on all these methods that you can use to find problem plans on a production server. We're not going to talk about that now. What we are going to talk about is when you have a specific query and you want to find the execution plan for that query. So you are a DBA and you have already identified the problem query, or you are a developer and your DBA comes at you with a steaming face saying, that query you deployed yesterday is wrecking my server, you need to fix it, it's bad performance. In all those cases, you know the query and you need to find the execution plan because you want to know why it executed slow. Let's jump into the demo. So here we have an example of a simple query, and I'm already in the correct database, so I'll highlight the query. And if you look at the query, you will see that there's a function called delay. Well, if my production query calls a function called delay, I probably already have an idea why it's slow. Obviously, this is a simplified demo setup where I deliberately use a function that is slow. In reality, it will never be as simple as this. But we're not talking about how to tune queries, we're talking about how to find the execution plan. And there's multiple ways. One of them uses this button, and I'll zoom in to show you. So it's this button. It's called the Display Estimated Execution Plan button. You can also use Control L. I don't like the term estimated execution plan, but I'll get back to that later. I call this the execution plan or the execution plan only to make sure that to distinguish it from other versions of the execution plan. So if I click it, and I already did this, you will see that a new window opens down there here that shows some pictures and arrows and text, and that is the execution plan. If you've never seen one of these before, you're in the right session. We'll talk about how to read it later, but for now, just take this from me. This is the execution plan. This is where, once you know how to read it, you can figure out what algorithm was used to get there. But that's not the only way you can get there. You can also use this button. It's this button. It's called Include Actual Execution Plan, another name I don't like. This is the execution plan plus runtime statistics. So I click this and nothing happens on the screen. That's because the button is a toggle. If you watch, you can see that it's now depressed, hinting it's enabled. This means that if I execute the query, it will first run the query. This will take a few seconds, but once the query is finished, you will see an extra tab appear down here where my arrow is now. And that tab will contain the execution plan. It should be done about now. Yes, there we are. So I click this tab and there we see the same picture we saw before, but there's more text, there's more data now. That's because now, after running the query, more data was available that was added to the execution plan, and that data is the runtime statistic. So we have now some information about what actually happened while the query was running. And that information can be valuable, but the price we had to pay was we had to wait for the query to finish before we even received the execution plan. And in this case, with a query that ran for 17 seconds, it's bearable. If you are working on a report that should finish in 20 minutes, but it takes 3 hours at this time, then you will understand that this option is not always effective. Yes, it's nice to have that extra information from the runtime statistics available, but if you have to wait 3 hours before you can even start working, you have some issues. And that's where I'll disable this button now, where this button comes in. So once more, I will zoom in and highlight it. It's called Include Live Query Statistics. I'm My zoom in skills are not up to par today. That should have been a box, but you get the picture. This button is also a toggle. I click it, it's enabled. So like the actual execution plan, this live query statistics is an on-off switch, and when it's on and I execute the query again, you will see that immediately an execution plan appears and it's animated and the numbers change. So what happens here is that we get the execution plan first, then the query starts executing, and while it's executing, Management Studio constantly polls the execution and updates the screen with new snapshots of the runtime statistics until it's done, and then it's final. This version includes less statistics than the execution plan plus runtime statistics, but more than the execution plan only. And if you have a query that's running for 3 hours, you probably can see the benefit of starting it with this option, and after 5 minutes or so, taking a look to see if you can already identify problem areas. Worst case that can happen is that you still need to wait 3 hours before you can actually do your work. But in the ideal case, you can get started earlier. And by the way, the two options are not mutually exclusive. I can also choose to include them both. And then I have this live query plan with the constantly updating statistics. And by the time the query execution is completed, I will also have the execution plan plus the complete runtime statistics. That, like I said before, includes a bit more information than you will ever get here. And that's in this new tab. The extra information is not directly visible on the screen, but it is visible in the properties. That's where you will see large differences between the two versions. So let's recapture the 3 execution plan types we saw. We saw the execution plan, just the execution plan. Or if you want to avoid all confusion, call it the execution plan only. This is also called the estimated execution plan, especially in SQL Server tools, and that term has taken flight, and almost everyone in the community uses that term. And I like it. I don't like it because it causes confusion. I have so often seen people claim, oh, it's just the estimated execution plan. When you actually run the query, it might change. No, it might not. There are situations where there can be a recompile, but if there's no recompile, then the execution plan is how the query will execute. And if there is no recompile, then the execution plan is actually exactly what will happen. And every claim that at runtime it might change, except for some specific exceptions, those claims are wrong. But the name implies that that might be the case, and that's why I hate that name. Second version we saw is the execution plan plus runtime statistics, which in the tools is called the actual execution plan. Well, estimated plan, actual plan, it's clear where the confusion comes from, but again, it is the same execution plan. The only difference between the so-called estimated plan and the so-called actual plan is that the second version has those additional runtime statistics. That's it. And then we saw the execution plan with live statistics, a quite recent addition, I think since SQL Server 2016, if I'm correct, where you also get the same execution plan, but you get snapshots of the statistics as the query is running. If there are any questions on this, let me know. Just unmute yourself, ask your question, or type it in the chat. I don't think I see anything in the chat right now, so I'll just keep going. There's an overview here, and I'm not going to read through all the details. You can download the slide deck later and look at the details, but here's all the important information for the 3 types of execution plans side by side, so you can compare them and understand the differences and the similarities between them. Now then, the most important part. We have found the execution plans, but how do we read them? I already told you there were some pictures on the screen and some letters and some numbers, and I said that's the execution plan. But how do you read it? If you've never seen one of those before, where do you start? Well, here is an example of a really simple execution plan. It's not the same one I think it's not the same one I used in the demo but it's similar. It doesn't really matter whether it's the same one or not. This is a very simple execution plan. Most execution plans are more complex, but the elements are the same. So I start with a simple version. And then if you look at this execution plan, you will see that there's actually only two elements. One of them is the icons. They all look different. They have different names, but all of them are icons, and those icons represent something called operators. And an operator is a small program that does something. It has its own task, and it does that task, and it does it very well, and that's the only thing it can do. Then we also have the arrows, and the arrows represent the data flows. And if you actually look in the details of the internals of the execution plan, you will learn that those arrows do not even actually exist in the execution plan. They are a visualization. I'll return to that later. But let's first focus a bit more on the operators, those icons, those small programs that all have their own task. Each of those has at the layer of the programming interface exactly three functions, three entry points where they can be called, or as .NET developers would call it, methods. So every operator supports an initialize method, and the initialize method is called when that operator needs to prepare to do work. It can also be used if it has already done work, but it needs to restart from the top. And that may sound ineffective, but there are cases where you want to do the same things multiple times within an execution plan. And then it's also possible that operators use a parameter to determine exactly how they work. And when you reinitialize it, the parameters can be changed. So that's also a way where it starts again, but because the parameter is changed, it now does something slightly different. And all of that can sometimes be used in execution plans by the optimizer to give you the results that your query asks for. The most important method, the method you usually focus on when looking at operators in an execution plan, is the getNext method. The getNext method is called when the calling operator wants to have a single row. So the calling operator calls another operator and says, give me a row. That's what getNext does. And the operator that is called with getNext has now the task to produce a row. How it does that, that's where each specific operator has its own way. A scan operator does something completely different from a hash match operator or a filter operator. They all have their own task. They are specialized to do that task, but the end result is always one row. And that one row is then returned to whoever called that operator, which in most cases is another operator. And most operators, when they are called with the getNext, also need to call other operators again. It's like one operator being called and gets the task, give me a row. And he says, yeah, I would love to give you a row, but I need to have some rows first myself. So I'm going to ask someone else to give me a row. It's almost like how work in a huge institution works. Everyone is asking someone else to do their work. Not exactly like that, but there are some similarities sometimes. I hope this becomes more clear as we talk more and as we run through some example later. The third method I only included here for completeness, but it's really not relevant. It's important that it exists. It's important that it's used because it prevents memory leaks, but it's the close method. It's called when the query is finished and all the operators need to clean up whatever stuff they have allocated in memory. That's it. I never, ever, ever have to look into the details of a close method. It's just there. It works. Now, the term operator is unfortunately an overloaded term. It has two related but different meanings, and only context can help you understand which it is. So the term operator can be used as the name of a generic type of operator. If you go to the execution plan reference, the website I'm building, and look at the page for the filter operator, you will see a text like, the filter operator applies a predicate to its input rows and returns only rows for which the predicate evaluates to true, which is a complex speak for something that you could simplify to, the filter operator runs a test on each row, and when the test is true, the row is returned. That's a generic description that applies to every filter operator. It's the class of operators that all have the same task. So the term operator in this context describes the class. But the term operator is also used for the instance of that operator class within a plan. So someone might send me an email saying, hey, Hugo, I attended your session, it was very useful, and I ran into this execution plan, and this is the query, this is the execution plan. There are 3 filters operator there, and I looked at the query, and I understand these 2, but that 3rd one, I don't understand why it's there. Can you help me understand why the optimizer added that 3rd filter operator? Now we're talking about specific operators within an execution plan. Each of those are part of the same class. Each single one of those 3 filter operators does the same basic action of applying a test to its rows. But they read their row from another source. They apply another test. They return other columns. That's why each individual filter operator does something different, even though they're part of the same class. Both cases, both the class and the instance, are called operator. That can be confusing, but most of the time, just check the context and it will be clear what is meant. So after talking about the operators, let's talk about those arrows, those data flows. I already mentioned they are not even really actual elements of the execution plan, and yet they are there. So what they do is they are a representation of which operators call which other operators, and by extension, it's also a representation of which operators return data to which other operators. It's important to know that, well, some terminology first. If there is an arrow, that means that an operator is called by another operator. The calling operator here is called the parent, and the called operator is called the child. That's just terminology. So the parent operator calls the child. Each child has exactly one parent. So every operator is called by exactly one other operator and returns rows to that one other operator. The reverse is not the case. Every operator itself can have 0, 1, or more child operators. A lot of operators have one child operator, but there are operators that have none, there are operators that have 2, and there are some operators that even can have unlimited amounts of child operators. The amount of child operators depends on the function of that operator. If an operator is built specifically to combine data from 2 sources, it will have 2 child operators for the 2 sources. Because this structure of each parent having 0 or more children and each child having exactly one parent, the execution plan is what mathematicians call a tree. That's a term from graph theory. And because in graph theory the terminology is nodes, you will find the term node sometimes used in execution plans. You will also find terms such as subtree and parent and child will also be used. Those are all terms that stem from graph theory. It's not important to realize to know graph theory, by the way. I just threw it in to understand where the term node comes from and subtree comes from, so you understand the terminology. So before going into more specifics, let's go through a few very popular and very common misunderstandings. The first one is related to something called the cost percentages. And I'll just go to a demo to show this. So in this second demo, and I'll just make sure that I'm in the correct database first. Yep, I have 2 queries here. So this is the original query, and I was asked to tune it, and this is my tuning attempt. And again, this is a very simplified demo. Normally I say do not use this option ever unless you really know what it does and you really know you need it. This way to tune a query is actually a terrible idea. This is not a realistic example. It's a simplified example to show something in a demo. Let's just assume that this is a complex, large query that ran too slow, and that this is my attempt to tune it. So what I sometimes see people do is highlight the two queries in a single batch and then click the button for the execution plan only. And if you click it, you get the two execution plans. Well, actually three, because this assignment is also results in an execution plan, but we'll ignore that for now. We'll just look at the two execution plans, and then you will see that the first query, the one that was slow, has a query cost of 99% of the total batch. The second query is just the remaining 1% of the total batch. So hey, look at this. I am a tuning god. I am awesome. I made the query go 100 times faster. I'm worth my paycheck, definitely, because look how fast I made this query, right? That's a misunderstanding I see a lot. Then sometimes I hear people say, yeah, but it's called an estimated execution plan, so these numbers are estimates. And then other people will say, okay, let's use the actual execution plan. And again, I don't like this terminology. This is one of the reasons, but people will do it. So I ask for the execution plan plus runtime statistics, and I execute the two queries in a single batch. And now I see the real execution plans, as people call it. And look, the same numbers. 99% for the slow query, 1% for how I tuned it. See, I actually am a query tuning god. I am awesome. I am the best you will ever find. Yeah, but I don't like this way of tuning or measuring a query. I wrote here tune, but I should say measure. So the correct way is to disable the execution plan, because that incurs some overhead, and you want as little overhead as possible, and ask for statistics IO on and statistics time on. And I'm going to run the same two queries again, and I'm going to look at how much time and resources were used. The first execution, it took 7 milliseconds. Elapsed time, 7 milliseconds of CPU time, and we used 689. I'm sorry, I highlighted the wrong part. The first, that was the parsing compiler. So the first query took 50 milliseconds of CPU, 21 milliseconds of elapsed time, and did 689 logical reads. So that's the number of pages that was read in the buffer pool. And then this query tuning god came along, this awesome, fantastic tuner, and the result is that the query now runs in only 79 milliseconds. Wait, that's more. And the number of logical reads is reduced, increased to 94,506. So what I actually did was I made the query 5 times slower, and it does 150 times more work than before. I am the query thrashing god. I ruined performance of this query. And I thought I did a great job because I was stupid enough to believe these numbers. And I should not believe those numbers. And I'll tell you why. This number is 99%, and this number comes from, and I'll hover over the select and zoom in, and then we see a number here, 0.58. And now I'll hover over the second select, and I'll zoom in again, and then we see that the same property has a much lower number here. And if you do the math, you will see that that's exactly 99% and 1% if you round it, and it's called the estimated subtree cost. Estimated subtree cost. Estimated. Even in a so-called actual plan, even in an execution plan plus runtime statistics, this is an estimate. It's the number that SQL Server thinks will be the cost of the query before it starts running the query. It's not changed when the query is executed. So SQL Server thinks that the second query will be faster, but SQL Server thinks wrong in this case. And very often, when your query is slow and when you need to tune a query, then very often the reason is that SQL Server is mistaken about the cost. So the estimates are very often wrong in the queries where you actually want to look at. The queries where you don't want to look at, well, you don't look at them. The queries where you need to look at, they often give you wrong estimates. And all those percentages, and not just this query cost, but also these percentages you see here, they're all based on the estimates, not on the actual numbers. So all those percentages are meaningless when your estimates are wrong. And very often when your query is slow, it is because your estimates are wrong. So please don't look at those percentages and think they are meaningful. They can be meaningful in some cases, but you need to know what the limitations are. I went through this in the demo, except for one thing. Even if the estimated row counts are correct, then the cost percentages can still be wrong because the numbers are based on rather outdated hardware assumptions. The whole costing model was devised in, I think, 1995 or so. And the basic ingredients of the costing model haven't changed since then. So the costing model is assumed all based on spinning disks, on limited memory, on if you even have multiple processors, 4 or 8 cores, and not 64. That was unthinkable back then. So all those cost percentages can be off. I'm not saying that you should never look at them, but you should be aware that they can be very misleading. The redirection is also a very common misunderstanding. If you look at an execution plan, many sources will tell you, oh, you should always read it right to left. And then there's some sources that say, no, you should read it left to right. And they're all wrong. The correct answer is that you should be able to read it in every direction. And I'll show you why. Remember, those arrows indicate which operator calls each other operators and how the data flows. So when this execution plan starts running, what happens is that the select operator, which is actually a representation of the client program requesting a row, so the select operator calls the filter operator and says, hey, give me a row. The get next method, remember? And the filter operator is like, sure, I'd love to give you a row, but I need some data first myself. Hey, table scan, give me a row. And table scan will be like, yeah, I can scan a table, that's my task. And if I scan a table, then here's your row. The filter operator, its task is to filter rows. So it looks at its predicate, at its logical test. It says, I don't like this row. I cannot pass this. Table scan, give me another row. And table scan will respond, yeah, sure. Here's your next row. The filter operator will once more look at the row, verify its test, and it's like, oh yes, this is a beautiful row. I love it. I'm going to return it to my parent. And the select operator then receives this row, and this whole process continues. Now what you see in the picture is the red arrows. Those are the ones marked get next, going left to right, in case some of the people in the audience are colorblind. The red arrows represent the order of control, the order in which operators call each other. The blue arrows, with no text below them and going right to left, those mark the order of data flow. When you read an execution plan and try to understand what happens, all of them are important. Sometimes you need to read from right to left to follow the data to understand what happens to the data. But sometimes you also need to read from left to right to understand when, for instance, an operator says, I'm not even going to call my child operator. I see a question in chat, so let me read it. Why is still present within the plan the cost percentage if it's so confusing? I mean, what are the situations when it's useful? It can be useful if you know and understand the limitations. If the estimates are correct, then it is much better than when the estimates are wrong. It also gives you insight in why the plan was selected. And for the record, I'm not saying to never use it, but just don't blindly trust it. Also, on a related note, there's a lot of stuff in execution plans that's completely useless at all and that you will never want to look at. But the cost percentages can actually be useful, just don't overrate them. And I warn against them very sternly because they are so overrated by so many other sources. I feel like I need to push back a bit. So often I read books or articles on website, or I see other presentations where people just zoom in on the percentages and say, oh, this is the 99%, so we need to look here. And they might be right. Maybe they are right in 75% of the cases. But tell people that it's not always the case. And because other people don't tell it, I tell it extra loud. So they're not useless, you just need to be aware of the limitations. I hope that answers your question. So we know why we care about execution plans. We know where to find them. We know that we don't read on left to right, not right to left, but a bit of both. And sometimes we start in the middle, sometimes we start at the edges, just wherever we see something interesting. There is no fixed way to read an execution plan. That's one of the things that make it interesting, that there's no simple method that's always correct. But one thing that's very important when you start reading execution plan is to understand properties. If this is an execution plan, then the graphical execution plan is just the tip of the iceberg. And most of the information, most of the stuff that you really care about is hidden below the surface. That's the properties. And let's go into a demo for those properties. So let's go into the correct database. And then I'm going to select two queries. The queries are rather different. There's completely different column selection, completely different where clause. So you would expect two different execution plans because the execution plan determines how the runtime engine will process the data. But when I ask for the execution plans, I see the same picture two times. It appears as if both queries use the same execution plan. That's weird. And then when I run them, the execution plan plus runtime statistics are also the same picture. It still appears the same. When I look at the results, I immediately see that the first query returns far more columns than the second. And if I click in the result set and then zoom in on the number of rows, I see that the first result set is almost 20,000 rows. The second result set is only 14,000 rows. So there is a difference. They actually do different things as we would expect. But in the execution plan, you don't see that. So how is that even possible? Well, if I hover my mouse over one of the operators here, you see a lot of extra data appear. Those are the properties. And when I zoom in here, I will see that there is a property called output list, and that lists 5 columns. The 5 columns I have in the query. So this property tells the operator only return those 5 columns. It also has a predicate property, and it says only returns rows that have this modified date. So those are two examples of properties that influence the behavior of an operator. The other execution plan looks the same. If I look at the properties here, you will see that there is no predicate property at all. So it passes all rows. And the output list is much longer, even so long that it couldn't fit everything on the screen. So it uses ellipses there. Now, if I want to have all the information, what I can do is right click and click Properties. And in my case, that will just focus this window here, and I'll pull it out. If you don't have this window open, it will open it. I always pin this window because I like to have it open all the time. And this is the list of all properties, and it's not shortened. So I can scroll down here, and in the output list, I can click the arrow, and then I can see all the rows, all the columns that are returned. Or I can click this ellipsis and get it in a text form in a separate window. All that information is available, and if you have this window docked and pinned, like I said here, I always pin it. So this is how most people have it, but I pin it so that I always see it. And once it's pinned, I can just click. And if you watch the right side of the screen, when I click on the left side on different operators, you will see the data change because it's always the properties of the highlighted element. Now, in this property list, you saw some properties that influence how the operator behaves, but it also gives actual data, like how many rows were actually returned. And well, the estimated operator cost, an estimate, remember, but it's also the actual number of rows that we see here, and something called the actual rebinds and the actual rewinds. What they are is not relevant right now, but all that information, those are the runtime statistics that are added to the execution plan if you actually run the query. And all those properties are extremely important to really understand the execution plan. So, like I showed in the demo, you can hover over an icon and then you get a pop-up that lists a subset of the properties of that operator. Not all of them. And which are shown and which are not shown is chosen by Microsoft, and you cannot configure that. I don't always agree with their choices. I think there's some properties in there that are hardly ever needed, and some properties that I need far more often are not included there. And I would love to be able to configure that, but yeah, I'm not. So there's a limit. It's easy to get this pop-up, just hover your mouse and it's there, but it's also limited. And that's why I far more often use the full list. I didn't show it in the demo, but you can also hover your mouse over an arrow. Now, if you hover your mouse over an arrow, as shown in the screenshot on the slide, you will also get a pop-up with just a few properties. Those properties are not properties of the arrow. Remember, the arrow doesn't exist in the execution plan. It just signals how operators call each other and how data flows between them. The properties you see when you hover an arrow are actually properties of the operator on the right side of the arrow. And it's a subset that's focused on the amount of data produced by that operator. So this is actually a very useful method if you quickly want to go through an execution plan to see how much data is flowing from where to where and where does the data disappear. And we saw the full property list that you can right click and that you can leave open. I showed it all. The benefit here is that it includes all the properties completely, nothing shortened, nothing left out. And if you just leave that window open at all time, you can just click an operator or an arrow or an area in the screen, and you will immediately see the properties of whatever you have highlighted. And then we have the property, the top left operator. And I already mentioned before, the top left operator is not a real operator. It's actually a client requesting rows. It's represented as an operator in the execution plan. And even though it's not an operator, there's lots of properties on there. Those are the properties that relate to the plan as a whole. So let's go return to the demo and look at that select operator, that top left. If I just hover here, you see not much. It's just a few things. They are useful, but it's not much. However, if you click here, and I'll drag out the properties window again so I can make it a bit larger, you will see that there's a lot of properties here. And some have names that immediately make clear what they do. The cached plan size, well, that's the size of the plan in the cache. There's also stuff that you are like, I have no clue what this does, and you might need to figure it out. And then there are some parts where you can click on the plus sign to drill down into more details. And I'm not going to go through all the details here, just go to show you there's a huge amount of data here, and all of this may or may not be relevant. All of this may or may not be immediately clear from the name, but it is very important to understand all of this. For other operators, I already went that the properties apply to that operator only, and they may change behavior or they may include measures of something that happened. Give me a second to read some questions. Do the missing index suggestions in the execution plan, are they any worthy at all? I would not take them at face value. They are relevant because they signal that SQL Server thinks, hey, this execution plan might be faster if there is a better execution plan available. But it's based on that single query only, and you hardly ever optimize for a single query only. It's also limited in what it can and cannot measure. So I would never blindly create the index it suggests. But it's definitely a red flag that, hey, this query might benefit from better indexing, and I need to look at it, and the details in the hint might give a starting point. I see another question. Stat statistics IO and time on requires to actually run the query. Yes, that is correct. One thing I did not point out, but if you actually run a query, and I did this now, and you go to the select, then you can also go to the query time stats, and I'll zoom in a second. So expand it first. And this now actually gives the same information as you get from query set statistics time. So if you already have an execution plan plus runtime statistics, you have the information available already, and you don't need set statistics time anymore. Set statistics IO is a bit more complex. The information is in the execution plan, but it's scattered through the different nodes. So in this case, there's only one operator. You can find the actual IO statistics here. And it's not really visible, but this is the actual logical reads, and this is the actual reads, I think. If you want to see the full name, you can just hover. Oh, it's the actual read aheads and the actual logical reads. So all that information is also available in the execution plan. Set statistics IO and set statistics time on are not actually as important anymore as they were. The meaning of all the properties is not in scope for this session. I'm already out of time. I wanted to do a demo. I don't have time for that anymore. I need to wrap up now. But you can find a lot of information on the execution plan reference. So I'm going to skip the examples. I have two demos where I talk you through the execution plan. Usually I try to do at least one, but I was a bit more wordy than normal, and there were some good questions that I wanted to address. So I'm unfortunately going to have to skip that. I do want to tell you, please look at all the extra resources you have available. The book SQL Server Execution Plans 3rd edition, use the 3rd edition, not the 2nd or 1st. There's huge improvements in every new edition. The 3rd edition is a great book written by Grant Fritchie. He works for Redgate. He's SQL Server Data Platform MVP. It's a great guide from getting started to at least intermediate level. And you can free download it. I've given you a tiny URL because I hate long URLs. It's a free download. If you want a DAT3 copy, you will have to go to amazon.com. You have the execution plan reference, a completely free resource. You have my own video training. And again, don't forget, until March 31st, you can get a 10% discount with the code DATASETPORD. And I think it's case sensitive. So screenshot this or remember it. There's also lots of good courses on pluralsight.com. That's all I have time for today. That's all I have. Sorry that I didn't get to the demo, but this is the end. If you have more questions after this, please mail me, tweet me. As I said before, I love engaging with the community. I loved talking at SQL Saturday in Pordenone. I'm really sorry I wasn't able to go there and sample your excellent cuisine. I'll keep a rain check for that. Thanks for your time. Thanks for your attention. Goodbye.